Hello ladies and gentlemen, I'm Wenyao Liu from OSU, the PhD student of Dr. Joshua Li. I'd like to introduce our study on utilizing pavement friction data for the reduction of traffic crashes and delays. Research shows that a large proportion of crash fatalities are related to inadequate roadway conditions. However, the safety performance function of Highway Safety Manual has not included the roadway features yet. This study aims to develop an enhanced SPF for highways in Oklahoma and then explore how the crashes can be decreased from the roadway conditions aspect. 4 datasets were provided by ODOT for this research. Safety database with crash data, skid study program with friction data, PMS datasets with condition data, and site manager dataset with construction and maintenance record. The team spent extensive efforts on linking and filtering the 4 datasets thanks to the differences in the data format, especially the location and interval. About 1,800 segments were filtered out for building up an enhanced SPF. The independent factors covered crash exposure, surface conditions, and geometry factors. Enhanced SPF based on negative binomial model is built and validated with good prediction performance. The modeling results reveals that pavement friction has significant influences on the rate of crashes. The question comes to how to consider pavement friction in decision making. First, determine the demand. Following the method 3 in the official guide for pavement friction, the investigatory level is recommended at 35, while intervention level at 30. Second, find the contributors. The results of statistical friction prediction model indicate that the air voids content and the percentage of fine aggregates have significant effect on the pavement friction. Third, compare the friction performance of pavement after each kind of treatment. It is observed that different treatment results to different friction performance. The aggregate type and the micro-Devil property of aggregate deserve more attention in pavement maintenance. Finally, it is of great interest to consider life cycle cost in decision making. By setting up the deterioration model for each treatment, 3 alternatives were compared in the virtual example project to maintain the friction level above the investigatory level. It is observed that the high-friction surface in treatment changes from the most expensive one to the cheapest one when considering the delays caused by crash. Conclusions of this study are summarized, and a special thanks gives to ODOT for their sponsor and technical support.